Hello.
Hey, Brother Savick.
Hey, Vonro. Hey, David. Alrighty. Another few minutes here. Sue shows up. All right. How are you guys today, and how can I help? Now, David, I know I spoke to you before, so you and I'll take some time after the main thing to discuss what's going on with you. Okay?
Yeah, no, sounds good. I don't really have any questions, kind of.
That's fine. If there are no questions, I'm just going to go over the slides, talk about the concepts for this week. You know, anything along those lines. It's kind of what I did last week. No one gave me any questions in the comments, so nope. I totally forgot because Monday was off to post a Monday announcement, so it's a little confusing. Couple of things. So a couple of things I'll let you guys know, and then whoever's watching this after the fact will know. They've changed things up a little bit. There is now, for the quizzes and the exercises, there's only one attempt. There aren't three anymore. And the final exam is one option how to end the class. There's now the option of doing a final project. I'll find that. They were supposed to post it out there today. I'll see if I can find it real quick and we can go over what that'll be. Let me see if I can find it. They said they're gonna put it in 3. It is not here in 3. Okay. When I find it, I will publish it out to you guys. But it's basically designing an ERD of, I think, 12 tables, writing some queries that go against them, normalizing them, and the like. So if you don't want to take the final exam, there's a final project to do. Move it here. No. 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 Okay. Alrighty. Let me open up the slides and let's go over them. Week 3. Okay, let me share my screen. Okay. All right, can everyone see the slides? Is that what we see now?
Yes.
Okay. So chapter 4 this week is all about filtering the data that we're getting at. We're using that where clause to eliminate some things and to get the things we want to see. Going down here, so we're setting up conditions. The where clause has a bunch of different operators we're going to discuss, different ways to format them, which we're going to talk about. But really, they're just setting up conditions saying the data must look like this or the data must not look like this in order for it to be shown. So the example here is where first name equals Stephen and create date equals 2006-101. So the first two basic operators are the and or the or. So and means both criteria must be met, and or means one or the other must be met. So if I ran this, where first name Stephen and create date is 2006 January 1st, it would only return, because that and is there, only return where the first name is Stephen and that create date is there. If it were or, it would bring all the Stephens and all the people that were created on January 1st, 2006. If you wanted to add another one here, like or last name equals Young, you can put those in parentheses. Now that does mean these will, it's just like math, these will go first in the order of operations, and then this will go. So you're basically returning this set first, and then this criteria is being filtered off of this set. So and or, okay? Then we have the not operator. Not operator is I mean, it's Microsoft SQL, it's T-SQL. So again, English is English. So in this case, where not first name equals Stephen or first name, last name equals Young, that means everything but that. So it's kind of a weird way to do it. This is the better way to do it here, using the greater than less than signs. Now, I should have just shared my screen and not shared just the slides. So I want to jump back and forth and show you some stuff. Just share my screen. Just share my screen, period. Okay. Okay. So what I want to show you real quick is, so here's a query that I've got. I got select title from film. Okay. And I'm just getting them all, taking them all. So I have this statement here where a title, and I can use the word not, and it will return everything. Trust me, it's returning everything but that, right? It's returning a lot of stuff. I can use this. Okay, or I can use this. Now, the difference is you've got not, which is one way to do it. You've got this way, and you've got this way. Okay, both are inequalities. This one here, I strongly suggest you do not use when it comes to text. It will work. It works just fine. But that is a numeric inequality that works for text. This is the text inequality, exclamation point equals. It's just, if you get used to using this one, you won't confuse anyone down the road. Because remember, part of being a developer, part of writing this code is writing code that the people 6 months, 6 years down the line are going to look at and understand, as opposed to, you just understanding it for right now. So, Oregon, these are all valid operators to get inequalities. Okay. Back over here. Okay. Most conditions will be equality expressions. You want to know where things equal this. So you can run this query, inner join, where on customer ID equals customer ID, where rental date is 2005/6/14. So let me grab this and show you something about this one here and why this is a thing. Okay. So put this here. Let me clean it up a little bit. Okay. Okay. So why am I doing this here with date rental date? So let me run this right here and you'll see the results. Okay. So we get our results, the email to customers who rented on this specific day. If I take this out and just do rental date, I didn't get any results back. So if you remember from the previous week, date and time are two functions that isolate, because this field is a date time field. If I do a rental date equals 2, what I'm actually getting is this. Let me just show you what that looks like for real. So this is what the rental date is. So if I'm saying where rental date equals that, it doesn't anywhere because it has its date time. So I'd have to like, grab this thing out of here and put that there. And then you'll return the one result. But no one's going to get that specific, right? So when you're dealing with date time fields, you've got to put this function in front of them. So then you'll get the correct date time back. It also works in this field too. You can put date time here. So you can see what's coming back. I showed this out because this is a point of contention for some people. It gets confusing. One real quick word here about aliases, these aliases here. There was a discussion in the essays last week about why aliasing happens. So there's a couple of reasons why aliasing happens. The first reason is because when you're doing a join statement like this, you have to identify where the columns come from. And you could, I think I said last week, you can easily just do that and get rid of aliasing altogether. But that gets to be a little, time consuming, and I'm not really good at typing, so I like to type as little as possible. So I can put the aliasing there. And you can use the as function. It works there too. So this way, we're going to be able to use it as an inner join. I'll use it as join and to just alias these out, so I'm not typing the full name. The other reason is, and I think this happens, I think it's next week or week after next in your exercises, sometimes you need to reference a table twice in a where clause, in a from clause. So you can't do from customer inner join customer. Without aliasing them, okay? So there's an exercise that you'll have to do. There'll be reasons to do it because sometimes, for if in an employee table, you might have like manager ID, and the manager ID is the other person's employee ID. So you're going to reference the table back to itself. Okay, so that's the other reason for aliasing, so we can use the same table multiple times in one query. All right. Good so far? Any questions? All right. Inequality conditions, we want where the date is not 24/16, so that we just drop this. And again, so this is, like I said, you can't use the exclamation point equal sign here because that is not a arithmetic inequality. It is a specifically text inequality. But you can put this one here so where it doesn't equal that. So if I went back to my query here and I put this there instead, assuming I didn't break anything by messing around with the query, it sure is a return. Yeah, way more stuff. Showing all my dates except for that. All right. Okay. So the where clauses aren't only used in select statements, they're used in delete statements. So we do have another modifier here where you're just taking the year out of the rental date. You want to delete where everything's 2004. You can use a range, the greater than less than signs, for anything numeric. Theoretically, it works with letters too, but it's really kind of dicey, so you don't want to play that game. Don't do the like command as opposed to the greater than command. So you can find within a range. You can also use a between operator. So we can take this here. And copy this. Bring this over here. Is this going to return stuff, or is this going to work right? So why didn't I have to put date here if I'm just using dates? Because I use the between command. Because that'll the times count in there. So between midnight on the 14th and midnight on the 16th. So when I look at my date, when I look at my times here, you know, it'll show me all the, no, it's returning everything. Oh, hang on a second. Problem here.
So on
You
that,
copy- What are you gonna say?
so on that, kind of going back, so on that does not equal operator,
Mhm.
I'm somewhat familiar with like Python, where yeah, that's the one that I usually use when it does not equal something. Did you say something that does not work with numerical values?
It's so here's the gospel according to me on this one. This one was developed specifically for numeric values. This one was developed in T-SQL for alpha values. So they both theoretically work in both cases. But for me, I like using this one only for alpha values, and use this one for numeric values. That's just my own coding. So they both will work, but I like to use them what they're used for. Does that make sense?
Yeah.
Yeah.
So is that like kind of the standard across the board when doing a query? Is most people are like, okay, if I'm doing numerics, like
There's no standard across the board for anything.
yeah.
It's you. What ends up happening is you get into your own, like, this is how I like doing things. And sometimes you'll work for a company that wants things done a specific way, and they'll specifically say you must write the queries using this notation with this blah 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 blah. Most times they're not. You don't. But the problem with that becomes if you get too niche in how you write queries, it becomes difficult for people to follow you to understand what you've written. So I really try to err on the side of like using things what they were meant for using, so there's no confusion. Like, because my job, I deal with code that was written like 5-6 years ago, and I have no idea what these people were thinking when they wrote the code. It just makes no sense. And so I've got to go in and see what operators are using, what functions they're using, try to understand how it works. But there are best practices. But mostly doing like big broad things like never use nulls. Don't allow nulls to exist in your database because they're bad. But as far as like operator concerned, it's just gospel according to me. So let me run this again here. Okay. So now between 14 and 16, we're getting the stuff that we wanted. Okay. But because I didn't put date here, it's okay because this is a range. So as long as that time is between those dates, you're gonna be it'll return stuff. All right. We have the in command, which allows you to do multiple possibilities. So you have G or PG. The values have to be in parentheses. They have to have the quotes around them, unless they're numbers, and then they don't have the quotes. You can also use subqueries. In this case, like, here, if you ever want to add another rating, you'd have to go in there and manually put it next to your hard coding everything. Here in a subquery, this will change depending on, what movies are out there, what movies have been added or removed. So this result will change based on this, because this is in flux. This isn't a consistent. This is consistent, always return, just G's or PG's. Never seen anything else in there. And just as you use in, you can use not in. So this query and this query return the same values. So I took this one, dropped it here, and grab the other one. That's not it. And grab this other one. Of course, I got the stupid arrows, so I gotta fix that. I'm just gonna take this, grab this here. This is fine, good, okay. Grab this, put it here. Okay, this returns, where's my counts? It's not here. Okay, put this one here, put the there. Let's just do top 10 here. Top 10 not work? Okay, let's not do top 10. And let's look at this one. And it's the same results. They come back. Okay. We're rating. Oh, that's the problem. I can't say it. Okay, so this one. Unknown column title and title field list. Oh. There we are. Okay. So now we're getting all the PNG movies. We go here. We're the one that's not in. It's the same 372 rows. Okay. Using wildcards, there are two wildcards that we can use. We can use the %sign, which just says anything. It gives me the beginning. Like I say, anything I want with a B. I'll put B, %sign, and it returns anything that starts with a B. If I do %sign, B, %sign, anything that has a B in it comes up. I can use the underscore, which allows a wildcard for exactly one character. So if I did, let's see, back over here. Here, where title, okay. Okay, this will return everything with a B. That starts with a B. Okay, but if I did, it returns something that has a first letter B, the third letter an N, and everything else can be whatever. Okay.
So,
yeah.
So does that underscore mean that the second letter can be whatever?
Yep.
And then you just add the %sign, and that just says whatever it ends in. I don't care.
Correct. Correct. So this one says the first letter must be a B. The second letter can be anything it wants to be. The third letter must be an N, and then anything else after that. So I just want to know what has that, what has those two letters in the start.
And it's not case sensitive.
No, it's not case sensitive. So that's a good excellent question, because some database engines are very case sensitive. Oracle is absurdly case sensitive. If I ran this query in an Oracle database, it would return no values because it's not a capital B. So that's one of those things about Oracle that makes it more interesting. But yeah, it is not. MySQL and Microsoft SQL are not case sensitive. Okay. So here's an example how you use wildcards. You know, where the second letter is A, the fourth letter is a T, and it ends in S. So like, I don't know where you ever actually do this, but you know. Slice is not valid in this position for the server version. Okay, you're being weird. And that fixes everything. All right, so we do this. And those are the only ones that come up. So it's got to have a second letter, A, a fourth letter T, anything else, but it has to end in an S. So you can use them with or ands with last name like Q or last name like Y. Nulls. So let's talk about nulls real quick. Nulls are the absence of a value. It's not even, if you put like a space in it, like it's like, you know, where you set the value of a column to a space, that's not a null, that's a space. That's a character, even though it's a blank character, it's a character. Null means there's nothing in there at all. Nulls can corrupt your queries if you're trying to write a query. If you have nulls in a column and you're using a where clause on them, it has the potential of messing up the returns because nulls don't behave the way that you would want them to or expect them to. So the only time you do, like, if you do like where return date is null, equals null or is not null, it comes back. But the reason why nulls are bad for databases is because they mess with your indexes. So you should not, if you're designing a database, you should not have a null, allow nulls in columns that have indexes on them. But in the case of where statements, if you do where return date is null or equals null, it'll come back with that. But if you try to compare a null against something else, you'll get weird results. But we need to tell you what they are here. So you can use is null, is not null, or equals null, or does not equal null. It all returns the same. Okay. Okay. So they're showing here, suppose you have to write define rentals that were not returned during May through August 2005. The first thing to do this for rental where return date not between 5/01 and 9/01 and September 1st, May 1st. Notice that none of the return dates are null because they won't show up because you're not looking for specifically for them. So you have to modify your query to say where return date is null. Okay. Yeah, this is a good point here. When you work with tables, you're familiar with, check to see what allows nulls before you write queries on them. make sure you know what's allowing nulls, because it'll change how you rate your queries. But if you're designing a database, if you're modifying or fixing tables, try to get all your null columns out of there, unless there's a very good reason for them. All right, those are the slides. Any questions on the where clauses? Because it's pretty simple. It's a pretty simple week.
I had a question.
Sure.
So why would you need to look for your nulls if there's nothing in them? Why would you want them to populate?
For in the case of this query here, you're wanting to find what videos have not been returned yet. So the application obviously leaves a null there if they haven't been returned yet.
Okay.
So in that case, you have to look for a null. Again, my soapbox, Gospel According to Don, is find another way to do it. Don't leave nulls there, particularly if you're indexing it. But that's why in that case.
So if you had a database with like a first name, middle name, and last name, and somebody didn't have a middle name, do you suggest just leaving the middle name column out then?
No, you can put a middle name in there. Just don't index the column.
Okay.
Don't put it. You can search on it, but don't index. Let me rephrase that. Don't index the column if you're going to search on the column. Okay. Because middle name's a great example, because not everyone has a middle name or a middle initial, or not a lot of people admit to it. So you'd probably leave that null, but that it wouldn't be like you wouldn't be searching for someone by their middle name or by their middle initial, unless like you were in a class trying to teach the point of it. Let me stop sharing here for a second and see if I can dig up the stuff on the project. If there are no other questions on this. Where clauses are pretty cut and dry. They can get very, very complicated or stay very, very simple depending on what you want to do with them.
So with all these changes that are happening to the course, like only one attempt on the exercises and on the quiz and so on and so forth, is this effective like this week or next week?
Next week.
Next week? Okay.
Yeah, next week. The thing was, it's since all the quizzes are open book, and open notes and open whatever, they didn't see a necessity to have multiple attempts since you have all the resources. Now, as far as the exercises are concerned, if you do anything wrong in them, or I will give you a chance to correct it and I will fix your grade, because that's just how I do things. So you won't have 2 official attempts, but I will give you feedback as to what the query was, and how to fix it. And then if you resubmit it, I will give you the points back.
Is there information posted yet about what is expected for a final project if we wanted to do one?
Yes, I am. I'm trying to find that right now.
Oh.
It's supposed to go live this week to give you guys time to do it. Did they put in week 14? Let me see if they put in week 14. They're supposed to put it in week 3 because we don't want people getting to week 14 going, wait a second, there's a project. Let me see here. Okay, I don't think it's been published yet, but let me dig up my notes on it, and let me see if I can find what they sent me on it, and then I will go over it with you. Yeah. Oh, it's in the master. That's why. Okay. Hang on, I gotta go to the master slides. Courses. That's it. There it is. Okay, so let me share this out for you guys so you can see this. Share. And I'll just give you a quick overview. I'm not going into much detail on it because this will go live this week, hopefully, as soon as I approve it. And you'll be able to see it for yourselves. So here it is. You will need, so here's all your reading assignments that go with it. You'll need to create an ERD model for a real world application with a minimum of 12 tables. Create a test case operations against the 12 tables. You should include an index that maps user interface, CRUD test cases, SQL file scripts that can support test cases, mock-up of user interface UI forms, and test case for SQL scripts. And then create a PowerPoint presentation that explains the business purpose of your model. So you got to come up with an application or an existing application, design a database backend to it, create test cases for it, create indexes, mock up a UI, and write some script files like how you'd insert into that table, how you'd delete from that table, how you'd select from that table, and how that would be presented. Would you create any views? It's a bit complicated, but it does embrace all the elements of what you'll be doing between now and week 13. I do not suggest waiting until week 13 to do it, but you know, unless you're really good, because I think it's actually going to be due the Saturday of week 13. That Saturday's when we do. But this is basically what we're looking at, and this will be in lieu of the final exam. So you're gonna do the project, you can do the exam. You cannot do both, because that would just be weird.
So if you're working on a database, normalizing is when you don't have multiple of the same thing. Like if I had a movie and I was like, I guess doing genres, because I don't know what I'm trying to say. I'm just trying to figure out what normalizing is and everything, so I don't like have duplicated data.
Sure. Okay, let me do this. Okay. Let's see. This is when I wish we were in a classroom and I had a whiteboard. Okay, so let's say you were doing a movies database and you had a table called movies, right? And in there you had title and you had director. And what else would you have in there? You'd have rating and genre and running time and plot. Sure, why not plot? Plot. And anything else you can think of that would go into a
year?
Year, good, yeah, year. Actors, actor. Okay, that's it. Okay, so let's talk about this. So this is our first pass, and we want to normalize this. When we are normalizing table data, we want to take out anything that is not specific to that movie or to that table topic. Okay, so also anything we want to take anything that might have multiple entries. Okay, so title, there's only have one title. Director, there might be more than one director. So we wouldn't want director in the movie table. Okay, so we would take this out. I'll put this over here somewhere. Text director. Okay, rating, they never re-rate movies, so there's only gonna be the one. Genre, sometimes movies fall into more than one genre, so put genre over here. Oh, you can't go back and erase. Okay, oh, that was okay. Okay, so here. Okay. Okay. So we don't want genre there. Running time, yes. Plot, yes. Year, yes. Actor, no, because there's more than one actor. So our movies table actually look like. Let me hang on a second. Okay. Okay. I'll be issued with Excel. Let's try it in Excel. Next time I'm try is draw. Okay. So we got our movies. We got our movies table. Okay. So the first thing we need to never call it is an ID. Okay, so we'll do movie ID. And then we'll have title. And then we'll have genre. Then we'll have rating. And then we'll have running time.
We can't see what you're typing.
Oh, I'm sorry. Let me share out everything again here. Is that better? Okay, sorry about that.
Yes.
Okay, so okay. Running time. And what else did we say was going to be there? Rating, running time, plot. Okay. Okay. So that would be in the movie, and we never pluralize. It's always just single. So movie table. So then we want to make a direct. Let's make a genre table. And in here we'd have genre ID. And then genre. Okay. But the whole process of normalizing, and there's like, I think there's 4 states of normalization, is that you want to make sure that the information in that table directly deals with the subject of that table and doesn't have any other possibilities in there. Okay. And also you want to make it so so there's 3 kinds of relationships. There's one-to-one relationships, one-to-many relationships, and many-to-many relationships in the database. Okay, so when you have okay, get back over here. So let's do, okay, let's say we have a an employee database, employee table, and a manager table. Okay. Let's do this. Let's stick with movies. Okay. So we got a movie table, and we got a director table, or an actor table. Okay. And here we have actor ID, first name, last name. Leave it at that for right now. That's all I really care about, right? So if we had actor in here, okay, if we would actor in the movie table, this isn't normalized anymore because this is going to have multiple entries there. So we would know like actor 1, actor 2. We couldn't do that. So we couldn't put it there. Okay. Same thing with director. Same thing with genre. And same thing with those 3. Now, when I talk about many-to-many, many-to-many, and one-to-many, and one-to-one, let me do this here just for reading. Okay, let's say we had a rating column, a rating table too. Okay. If I were to connect the movie table to the actor table, okay, I would have a situation where one actor ID could connect to multiple movie IDs, and one movie ID can connect to multiple actor IDs, and we don't want that. That's bad. Okay, many relationships confuse indexes and searches. Take rating in here. Let's say I had a separate rating table. I'll explain why we'd have a separate rating table in a second. Let's say we have a separate rating table. Okay. And I just had rating ID in here. One movie can only have one rating. One rating can belong to many movies. So this is a one-to-one relationship this way and a one-to-many relationship that way, and that's totally fine. So we connect these tables by these columns. Okay, that's normalized. Now, why would we want to put a ratings table in play as opposed to have the rating, just a rating in the table? Why would I just want to put PG, G, whatever in the movie table? Why would I want a separate table for ratings?
Because there's more than one choice.
True. But that doesn't really factor in here. The reason why we want that is because a movie's rating may never change, but ratings themselves may change. Okay? Because like I forget, like in 1985, 86, whatever, PG-13 became a thing. So they added that into here. But also, you know, what denotes an R-rated movie versus what denotes a PG movie may change. Okay? So if we have a situation where it's possible that the data may change in a significant way, it'd be easier to change it one time here than like 1,000 times here. Okay. A good example would be like a database for ward and stake boundaries. Okay. So because it's one ward building to one stake, right? But that could change quite often depending on, you know, what's going on with populations in the area. So they're not going to, so they wouldn't have the stake name in the table for ward. It would be a separate table. But in this case here, I could have a rating ID here and then join these two tables together based on rating ID, because this movie to ratings is one-to-one, rating to movies is many-to-many. One-to-many, rather, one-to-many, okay? So this is good healthy, this is good normalized. Actor, we couldn't put actor ID here because multiple actors can be in one movie. And I couldn't put movie ID here because multiple movies, one movie can have multiple actors, okay? So we'd have to normalize this. I would put another table called movie actors. And it would have MAID, movie ID, and actor ID. Okay, so now, if I spelled that right, it would probably be better. Now, in this table would be a movie ID and a paired to an actor ID. So the movie table would have a one-to-one here because the actor can only be in a movie once. You're not gonna have multiple, you know, Dustin Hoffman's in the same thing. And the actor ID would be one-to-one here too. So it'd be one-to-one here, one-to-one here. Okay. So this is the next step in normalization, creating what I call bridging tables. First step in normalization, we get all this stuff out of here, and then we link the data the way it needs to be linked. Okay. This also is a good example, like for foreign keys. So like this and that would be a foreign key. This and that would be a foreign key, and this and that would be a foreign key. Okay. Because remember, foreign keys, we talked about them week 1. If it's not, if this table is foreign keyed to this table, it cannot exist here if it does not exist here. Okay, so we want to get these foreign keys going, and that's going to help our searches ultimately along the lines. Okay. Is this answering your question? I tend to go deep diving into this, so.
Yeah, so essentially we need foreign keys to link them.
You don't need them, but they help. Because if I had no foreign keys here at all, okay, foreign keys do two things. Foreign keys, first and foremost, ensure data clarity. It's consistency. Because if I didn't have a foreign key here, but let's say I had like 37 movie IDs here, and someone put like 83 here, and there was an 83 here, okay, the foreign key would stop that from happening. But if someone wasn't paying attention and put the wrong stuff in, these tables would no longer match up. So foreign keys are first and foremost, they're not about searching, they're about data consistency. They're also about searching because a foreign key is also an index. So now these two columns are linked together. So if I return from here, I'm automatically returning from here. And if I return from here, I'm automatically returning from here. Okay. So I don't want you to think that you have to have foreign keys. There are some situations where you don't use foreign keys. For example, if you know the data is not going to be consistent, let's say you've got a very volatile database and you know that the data is not going to be consistent, you wouldn't use foreign keys. Let's say you're doing a mass, let's say you're doing a like you own a video rental store and you're about to you bought someone else's video rental store and you're merging the data right into one database. You don't want to have foreign keys in place because they may blow up. So you take the foreign keys off and then you import the data in, and then you fix it later. Okay, there's other ways to do it, but anyway, so but yeah, so foreign keys there to protect your data and help your searches, which has nothing to do with normalization, but which is kind of where we started from. But the key thing about the key thing about normalization, remember, is again, the key thing is if it doesn't make sense to be there, it shouldn't be there. Here's a good classic example of normalization. So we've got employee, and then we got first name. We have employee ID first and foremost. We have first name, last name, address, street address, city, state, zip, okay, and phone number. And then we have an office table. So I can do this. We have office ID, building, room, phone number. Okay, so I've got an employee table in my database that has employee phone number, let's say office phone. Okay. And then we have an office phone number here. So the question is, when we're talking about redundant data, we're not just talking about the redundant data in the same table. We're talking redundant data in different tables as well. Redundant data here would have like actor 1, actor 2, actor 3. That's redundant data, okay? We don't want that. Over here, I've got an employee table with his office phone number here and office phone number here. It's gonna be the same phone number. That's redundant data. So how do you figure out where the phone number belongs? And this is a trick question. The answer is, because everyone knows it's a trick question, is it depends on what your company wants. So the question is, so there's a phone number out there. Is it attached to employee or is it attached to the office itself? And that's something only your business can answer. If it's attached to the office, it belongs here and not here. But if the employee takes the number with him when he goes somewhere, then it belongs with the employee. Does this make sense? Okay. So that's where you have to figure that. So normalization would cover into redundant data between two different tables as well as the same table. Okay. Over normalizing a database, like for example, say this one here's just a normal phone number here, right? In cases like this, remember I said you wanted to make a separate rating table, right? In case like the data here changed, it's better for searches. It just makes it a smoother transition, right? So when you look at the employee table, you could take this information and put it in a separate table, and that would be fine. So if you want to take like this and make a separate table like that and put like, you know, call it, I don't know, so city state zip ID, okay? And then put that here, okay? And you have a city state zip table, okay? Okay, why is that? Okay, Control C, yes, Control V, oh, that's okay. So then we'd have a foreign key from here to here, okay? Now, why would we do that? A couple of reasons. In the grand scheme of things, it becomes easier to search this table because we can search here for city, state, and zip and only deal with the 3 columns and then take this ID and go over here and get it from there. So it's a faster search, okay? That'd be the number one reason why. And this is a fairly good example. It's an example of like stage 3 normalization. We're just trying to make things run faster, smoother. What I would not do is this. And I've seen this done, and I had words with the person that did it because it was a professional setting. So they had a city table, a state table, and a zip table. And that all went over into the employee table. And the problem I pointed out to them is a city can have the same name, and it was over normalized. Okay, so you gotta be careful when you're normalizing because you can't go too far sometimes. If you just remember, no redundant data in tables or across tables, and keeping the one-to-many and one-to-one and one-to-many relationships prominent, and getting rid of all many-to-many, your normalization will be fine. And it's very rare also that in a corporate setting, one person is designing a database on their own. It's usually a community effort because a database has many different facets to it. So if you're doing a database for a movie rental company, you know, one person would have take part of the database that just dealt with movies and that part. One person take care of customers. One person would design the schema for employees, and they would all merge it together at once in one database, as opposed to one person doing the whole thing.
So for the movie _ actor, would that count as like a 4th table, or it wouldn't count because it's being like automatically needed since you have a many relationship?
It would count as a 4th table. It would count as a table.
Okay.
Yeah, it would absolutely count as a table because it has its own schema. It's got its own indexes because this would be your primary key, right? So yeah, it'd be its own table. It's funny, and back in the days of in-person teaching, when I would teach this, I would like, if you take a database and try to design a database and just make your 5 basic tables, like for a movie rental company, movie, employee, customer, rental, you go from like 5 tables to 15 tables very, very quickly because of normalization. But so you just look at the mindset, you know, is everything here like here with here, you know, who does the phone number belong to? Does it belong to the employee? Does it belong to the office? And that's where we got to make sure it goes. It goes to the right place. Okay. David, Ivano, you following this? You understanding it all?
Mostly. I
Yeah,
kind of
same.
start putting together like the information as I'm like doing it. I'm like, oh, okay,
Yeah.
that makes more sense now.
I love design databases. I used to teach in this room that had like all the walls were whiteboards. And so I could like just go to town, like design database across all the 4 walls, which is really super fun. And it's sad that I think it's super fun, but it was super fun. But yeah, so if you just start drawing it down and doing ERDs, you can do ERDs. I don't think you guys have access to an application called Visio that you can do ERDs in, or you can just like do them by hand and draw them out. If you decide to do the project, and you do hand drawn stuff, that's totally fine. Just scan it in and send it to me. But ultimately, go ahead.
Can we build it in Workbench?
Sure.
Okay.
But I need to see the ERD.
Mhm.
Okay. Yeah. And one of the things you need to do is you got to send me the scripts that build everything. So if you want to build and then script it all out and send it, and I want to, because I'm going to take that and I'm just going to run it on my Workbench and see if it works. So that's how I'm going to check all your stuff. I'm going to take your code and run it and see how it works. And I'll look at the design and stuff. So, but that's pretty much normalization in a nutshell. If you're doing the project, and hear any questions or questions or thoughts, shoot me an email or pop in on a Wednesday and just show me, and we can talk about it. Like if you're not sure something's normalized properly or how something would flow, we can have a lot of time on a Wednesday to that. Any other questions? No? Okay. Okay. Well, if that's that, then I'm going to end tonight. And David, stick around. You and I'll talk in a minute as soon as we end the session. I stop recording. Okay. Okay. Bye. Thanks for coming. Thanks for coming down, guys.
Yeah, thank you, brother.
Let me stop.